Hello everyone! This video will be on the 2.5 section of the IBAA curriculum. Please pause the video for a second to look at the concepts and contents for the section. There are no formulae for this section. One sentence that summarizes this section is that you can take an output of a function as an input of another function. The first thing we should remember is the independent variable and the dependent variable. I told you earlier that x is usually used as an independent variable and y is usually used as a dependent variable. However, they're usually used, not always. Y could be used as an independent variable, 3x could be used, t could be used, or even a dependent variable of another function could be used. It's important that they are variables, so anything can be used, as long as the domain is kept. When a dependent variable of another function is used as an independent variable, the function is then called a composite function. The word composite literally means that the function is made up of different parts. As you can see from the notation, the input of the f of x is now g of x. That is possibly because of the freedom of the function notation, which is why people often use the f of x equals something instead of only sticking with the y equals something. We read the composite function as f of g of x. Imagine the composite function as an animal eating another animal, such as, I'm not an artist, but such as a snake eating another snake. That is totally a valid drawing. I don't know what I'm doing, but yeah. We could have a bigger composite function such as f of g of h of x. Let's try out some examples. I believe this topic is much easier to understand with some easy examples to start with. Let's say we have f of x equals 3x plus 2 and g of x equals negative 2x minus 3. Okay. Then we could write f of g of x as f of negative 2x minus 3. And in the place of where x was for f of x, we put in the negative 2x minus 3. Therefore, it becomes 3 negative 2x minus 3 plus 2, which in turn is negative 6x minus 7. Straightforward, right? Even with more complicated situations, the process is still the same. One thing to note is that sometimes the g of x may not be explicitly given, such as the question with f of 2x squared. In this case, you should notice that this is a composite function question, and you could also define your own function here, such as L of x is 2x squared. Then this becomes f of L of x. The significance of the composite function comes very clear when we learn about the calculus in topic 5. I hope to see you there. Now, let's move on to the inverse function. Inverse function? Perhaps you have heard of the inverse notation. Inverse notations are notations that nullify the counterparts, such as plus and minus, multiply and divide, or squared or square roots. Notice doing one and doing the other produces the same output. The same idea applies here. The inverse function is the function that reverses the original function, aka the output back to the input. We write it as f like that, and just read it as an inverse function of f. Again, let's look at some examples. Let's bring back the f of x equals 3x plus 2. With the given x, what does f do? Well, according to the bed mass, or the order of operations, 3 is multiplied and then 2 is added. To reverse this process, well, 2 should be subtracted and then divided by 3. Simple enough, right? For inverse functions, however, it gets quite complicated when there are multiple appearances of x. Let's take h of x equals 2x over x plus 3. The same approach is quite difficult. Then, we could use an algebraic method. First, we can rewrite using the y. Y equals 2x over x plus 3. And then we can switch the positions of x and y because the inverse function takes output and puts it back to the input. So we're going to switch y to x and switch x to y. Then we're going to solve for y. There you go. The composite function of inverse function and the original function together produces the same input. Something like that. This composite function is called an identity function. In math, the word identity is used to describe when there is no change done with the operations. Therefore, the f of x equals x or y equals x. Make a note of this for a second. The inverse function also has a graphical significance. Let's plot the functions to the graphing calculator and see what we get. Let's try the f of x first. 3x plus 2. And then x, let's bracket around it first. X minus 2 divided by 3. Do you notice anything? Let's try with the h of x as well. 2x divided by x plus 3, and then negative 3x divided by x minus 2. Do you notice something? Yes, they're reflective to each other. Over what line though? It is reflective over y equals x. Let's plot the y equals x here as well. X, and then maybe let's put another visuals. Perhaps something like dotted line like that. There you go. See how it's a reflection. Remember from a few minutes ago? The identity function was y equals x. What a coincidence, right? One way to see your inverse function without having to algebraically finding the inverse function is to use a feature in your graphing calculator. Let's clear the second function. And we go to the main menu, and then let's press second draw. Let's go down the menu. And on the number 8, you can find the draw inverse. Let's press that. And then we have to open up our y1. So press vars, right click, function, and then y1. And then we can just press enter one more time. And we can see the inverse function. However, you cannot trace or calculate anything because this is merely an image. Quite useful if you want to know the rough sketch of the function, however. I hope you enjoyed this video and try some questions in this section to really master the skills that we have learned. Anyways, I'll see you in the next video. Best wishes!